Hello, everybody. This is Bill Bittner from IBM. Our next speaker is Emily Hugenbruch. Emily has worked in a lot of different areas in ZVM over her career, so she knows an awful lot of things. She's fixed things, she's broken things, and everything in between. I will turn it over to you, Emily. Thank you.
Cool. Thanks, Bill. So, like he mentioned, I've been working in ZVM for quite a few years now. Maybe that's not really a long time in the grand scheme of ZVM, but I've been here 14 years. In case you're wondering about the last name, I am not the security Hogan Brooke. I can't even pick up the security hammer. So please don't ask me questions about RACF. But I started out in component test. I think I saw we have Tim Greer on the call. So Tim taught me pretty much everything I know about taking dumps and breaking things. And the big project I worked on there was SSI and LGR. I then moved into development on ZVM, and the first thing I worked on there was SMT support. And then I moved around to systems management, and I worked on our OpenStack support. So loved seeing the presentation about the Cloud Infrastructure Center, because obviously it's morphed into that now. And then a couple of years ago, I moved back to the core hypervisor, and I'm now the team lead for the memory management team. So I think Bill mentioned this in the platform update on Tuesday, but the big project we're working on right now is 4 terabyte support and dynamic memory removal. So we're really excited about that. I want to say some thanks in this presentation. I already mentioned Tim Greer, but several other people have helped with getting this presentation together. And the idea here is really, it's a little bit of a fun session, I think, for a Friday afternoon to look at what to do when things go wrong. And I was really lucky that I got to start in component test. And so I got to investigate different types of problems. It was my job. It was a little bit fun. I got to take different types of dumps and get used to that. But now when I'm on the development side, especially when I'm working with service, I've noticed that a lot of times when things go wrong, it's usually the first time that a customer gets the experience of taking a dump, processing a dump, maybe looking at certain things in the HMC or SE. And so I wanted to do this session to give you a little bit of a taste of what it's like to take some of these different kinds of dumps, some of the things that we look at when things go wrong, and give you that experience when it's not a crit sit, so it's a little bit more fun. Like Bill mentioned, I'm happy to take questions at any time. If you type them in the chat, I'll try to keep an eye on that. So we'll go through and we'll kind of work through from least bad, I'll say, to most bad type of problem. So if you started with the issue that you can't reach your Linux guests, that's probably a symptom of what's wrong. Hopefully it's just something like the Linux guest doesn't have networking for some reason, or maybe the Linux guest accidentally got logged off. But then we'll go down from there to all the way to the sort of most bad scenario, where it's actually that the whole ZVM system is hung, and it's hung to such an extent that you can't log on to any user ID, you can't get the PSW restart, and we have to take a standalone dump. So let's get started. So the first thing we want to look at, if you had, say, a networking problem, you couldn't get to your guest, I think you'd probably want to go and try to actually log on to the ZVM user ID. So hopefully everyone is familiar with what it looks like to log on to a ZVM system. I have one of my favorite test systems up here. It is one where I designed the logo screen myself, so I'm kind of proud of the little puppy dogs. And so, I just log on to the Linux guest, and hopefully, I can see that he's up and running. Hopefully I could do some kind of a command. This is quite an old Linux guest. So, this one, obviously I can't reach over networking because he doesn't have any networking set up. I could issue a CP command. We always preface those with a a #CP. Look for like a query virtual NIC. He doesn't have one, so that's probably this Linux guest's problem, but a little bit of a simplistic example, but hopefully that's pretty fixable. Now, if it were up and it did actually have networking associated with it, maybe you'd want to then investigate the vSwitch, make sure that that's okay, make sure it actually has OSAs attached to it. I might have done that once or twice where I set up a vSwitch without any OSAs, and it's hard to get external connectivity that way. And you know, you might want to ask your networking people. It's always good to blame it on the networking people. Ask about the subnets and were there any hardware issues, things like that. So that's not too bad. It's a little bit of digging, a little bit of a annoyance with the network, but you should be able to get back up and running. Well, what if you think that the Linux guest is up, but you can't log on? So, you know, we saw when I logged on and I did the B command a couple times. So that stands for begin. So I'm just making sure that I got a Linux prompt. But if I did that a couple times and, you know, I couldn't get a Linux prompt, there was no way to actually interact with the Linux guest, that's probably that the guest is hung. So, you know, it's a good sign that I can actually log in from the green screen, but it's not such a good sign that I can't get a Linux login prompt. So there I probably do a # system restart, or I could use Standalone Dump. Like I said, we'll look at Standalone Dump in a bit. If I have kdump configured, system restart actually sends a signal to the Linux guest and causes it to take a dump. And then, of course, you could open up a PMR or Salesforce case and send it into our friendly Linux folks. So that's not great, right? You had a Linux guest that you really honestly couldn't get working, but it's not the end of the world. It's just one guest. You can get that restarted. Maybe that didn't really help. You know, after Linux took its dump, maybe it didn't come back up. Maybe it didn't really do anything when you did a # system restart and you're kind of like, ooh, what's going on with this? Maybe you had some trouble logging into it. Well, it's always good to try turning things off and turning them back on again. And the way we do that with our guests is force an X Autolog. So force is kind of nice. It sends what we call a signal shutdown to Linux, and it gives Linux a little bit of time to respond. Now, if it's hung, it probably can't respond. And so we'll just sort of wait the maximum time and then force it off. So if you want to see what a force an X Autolog looks like, I'm going to switch to a different user here. So here I'm Operations, and that for a very good reason. Operations has plenty of priv classes in order to do a force. So I could do a force LGRLin22. And there you see that signal shutdown is 31 seconds. And after that time, he should get logged off. And because we're kind of short on time here, I'm not going to wait the whole time, but oh, there he went. So that's great. And then to start him back up, we can just do, once I get my cursor back here, which of course my host on demand is going to freeze. So it's a typical thing that happens during a demo, right? But not to worry too much. We'll get it back here. I'll log back on to Operations. I'll remember that it's log on by. Someone in the security realm told us that all of our privileged IDs need to be log on by now. I don't know who that was, but not super happy with that person right now. So I think there's a question about force and signal shutdown. So they're similar. They'll both send a signal shutdown. I don't think that signal shutdown would actually log the guest off, you know, especially if he didn't respond to the signal shutdown. Force makes sure that he's actually going to log off at the end there. And so just log him back on. Hopefully now he's all happy, all back to normal. Things can go wrong with log off with force and X Autolog though. If the guest is really and truly hung, and at this point we're starting to get away from problems that might be something in Linux, and we're starting to get down into problems that might be something in the hypervisor. Sometimes force doesn't work if he's really, really hung. So query names might still show him even though the shutdown signal time has expired. If you do a query of the user ID, you might see this weird message that says log off force pending for the user. Every once in a while when I see this, it's some kind of a temporary issue because maybe there's a misbehaving device and it's sort of waiting for the last of an IO to finish up. A lot of times, especially here in the lab where we're trying to break things, it's going to require an IPL to clear up. But at this point, it's still, if we think about this in the grand scheme of problems that can happen to your ZVM system, it's not the worst thing in the world. It's just one guest. It's not multiple guests. So we don't maybe want to take the whole system down in order to clear this up. The other thing that could happen is maybe you can't log on to the ZVM user ID. Maybe you can get a log on screen though and log on to another guest. Like you saw, I was logged on to operatins. Operator and mate are also good Class A user IDs to log on to. So you want to query the guest. You know, maybe it's just as simple as the guest was logged off and you need to X Autolog them to get back on. That happens sometimes. Of course, you'd be able probably to log on directly to the guest then too and restart in that way. I just want to put in a little advertisement here for having something like Operations Manager to manage your guest consoles. So if you have to remember yourself to put spool con *start somewhere in each guest's directory entry or profile exec and manage all those yourself, chances are you're not going to have it when a problem comes up. I think just a couple months ago, I was actually working with a customer and I said, oh, do you have the console log? And they said, oh, no, because our spool filled up and we're not using anything to manage it. And so I don't have any consoles. And that makes debugging a problem a lot harder when you can't see what messages came up on the guest. So always, if you can, try to get some kind of tooling in order to manage that for you, because chances are if you're doing it as a human, you're going to forget and make a mistake. All right, so let's say either the guest is stuck in log off force pending, or we were having some problem where we couldn't even log on to him, or the force wasn't working. So at this point, we want to get a snap dump. A snap dump is going to temporarily quiesce our system, and it's going to dump things and then start the system right back up. The command I like to use for it, if you're on 7.1, I like to use this, go back here, snap dump PGM blocks all, frame table yes. This is because I work in memory management, and so when I have problems, I like to see the memory management structures. The downside to that is that the memory management structures are kind of a large part of a dump file, and this will, especially if you're running something like a 2 terabyte system, result in a larger dump file. So pros and cons, it gives us a lot of information, and of course at this point we really don't know what the problem is. You know, it could be in memory management, as much as I don't like to think about that possibility. It could be in I/O or CPU or kind of anywhere. So if you have the spool space and you have the time, we do appreciate it when we get dumps with PGM blocks and frame table. So let's try this command out. Go back over. I'm going to definitely need to be on my privileged ID again. That is not the right thing because it did not copy. That's some music I was trying for last time and it did not work. Okay. Ooh, that seems worrisome, right? I entered the command and I got that X clock. And now this is a really small system and there is not a lot going on. So we saw it came back pretty quick. If I had a larger system, I would probably see that X clock stay up for longer. You saw kind of an X down here. That I know when I was first taking a snap dump, I really worried that I had done something wrong because it seemed like all of a sudden my whole system was out. Well, there's a reason for that. The snap dump, as soon as you enter it, is going to take the system and do a dump. It kind of freezes it, dumps all the memory, and then brings it back. But of course, that meant that because I was doing this just from a regular telnet session, telnet server is down too. And so it didn't actually put up the message until it came back. So just something to think about, something to be a little bit aware of, especially if you're doing it from a telnet session like this. Don't worry, that's what it's supposed to be doing. So where did that end up? So I'm just going to do an IPL of CMS here, because there are lots of good things here on our Operations ID. It tells us a lot of good information about the system. It also looks what's in the reader of Operations. So hopefully everybody knows what a reader is. I think of it kind of like an email inbox for VM. And in this case, what's shown up here is our dump. You can see the type over here is an SMP001. So that's the type of a snap dump. And looks like it's there. So now I want to load it in. So I'll choose dump load 2. It says, yep, this is the one that I found out in the reader. So is that what we want to read in? Yes, it is. Nope, I don't want to continue. This is one of the reasons that I really like dump load 2 over the old dump load. And that's because the old dump load used to try to read it in and would run out of space, and then it would actually put it into a holding state, and you had to change it to no hold and a whole bunch of extra steps. Here, it just doesn't try loading it, so I can go to my disk and clear out my other dumps, right? So the other thing that dump load 2 can do is chunk up a dump file into multiple chunks, which makes it a whole lot easier when you're FTPing it into IBM for service so that we can look at it, because if it's one giant file and something goes wrong with the FTP, you have to redo an entire giant file, whereas if it's multiple smaller files, hopefully you just have to resend one or two. In this case, the dump is not that large. My system is not that interesting. And so it's going to take a little bit to read it in. So I see we have a question. Why does the snap dump cause the LPAR to go not operating on the HMC? Scared a lot of people. Yes, it did. So the thing about the HMC, and I will bring it up right over here. So here's, if people haven't seen it before, here's the hardware management console. These are the different systems, the different CACs, and then these are the partitions on that system. Here is my particular system. And you see here it says operating. Some of these others say exceptions or not operating. So this status is about how it looks to LPAR. And so when you're taking a dump or a snap dump or anything like that, and the processors aren't working, it's going to look like not operating to the HMC. And then when it comes back, it'll come back as operating. But that's not really saying anything about what the VM system is doing. It's just saying, well, the processors weren't really working at that point. And we'll actually see that a little bit better when we do a PSW restart. Okay, so at this point, we have a dump and you can send it into IBM. We'll use VM dump tool on it, which you can do on your own system if you'd like. Probably you're not going to get a whole lot of interesting information out of there because you're not a ZVM developer, but you can look and see, well, there's our snap dump that happened. Here's some of the system information. These are all the different processors we had. Keep in mind that if you have cores, so you'll see one for each thread on a core, because we treat those as their own logical processors. You can do look at the last trace entries. That's something that we would look at. The VMD scan shows you all of the user IDs that were logged on. That's interesting to you. So there's a lot that you can look at, but at this point, you're probably just opening up a PMR and sending it into IBM. So we saw that. I want to mention, usually it's operands that dumps go to. That is like so many things on VM configurable. That's in your system configuration file. The system user IDs tells you where it's going to send dumps to. All right, so maybe you did that maybe in a really good lucky kind of scenario. Doing the snap dump kind of stopped things and maybe cleared out like whatever IO was going on to your user ID, so it was able to fully log off, and maybe that cleared up the problem. But maybe it didn't. Maybe you're in an SSI. So it's a little bit different in an SSI. As you know, our users in an SSI are divided up into different types. There are those multi-configuration virtual machines that are identity in the directory, and the single configuration virtual machines that are users in the directory. So if you're in an SSI and you're trying to tell what's hung, I always recommend logging on to an identity or multi-configuration virtual machine. This is because if something happened with the SSI communications, for instance, someone tripped over one of the CTCs and pulled them all out, then the members can't communicate and they'll prevent any of those regular users from logging on. So, but the good news is a lot of your privileged users like me and operator and operators are all identities. So one thing that I always check when I'm in an SSI and having trouble getting a logo screen or logging on is going to another member of the SSI, trying to do a query SSI to see the state. And hopefully it should show everything's up and running and happy, but if it shows something down, you could always try to restart the links. Activate IS-link is the command to do that. In some cases, that may help. And just in case you haven't seen a query SSI command, it's just like that. It shows you what the whole mode of the SSI is. So this one's pretty happy. It shows you all of the systems joined to it, and the last time that they checked in, both with that persistent data record and with each other. So, that's just another thing to check that hopefully isn't quite as bad. Hopefully you could just reconnect those links that tell people to be more careful in the data center and not trip over things so much. All right, but maybe that didn't work. You just can't seem to log on to anybody, or there are a whole bunch of users that you can't log on to or that are stuck in log off force pending. Maybe the system is just really incredibly slow. You're typing in a command and it seems like it's taking forever just to get the command response back to you. So at this point, I think it's probably time for a PSW restart dump. And this, you'll notice it's a restart dump. And if you recall back to when we were logging on to our Linux guests and trying to restart Linux, we did a system restart, and that sent it a signal that caused it to restart. Well, a PSW restart is the exact same thing, but it's LPAR sending that signal to the ZVM system. So same thing, a restart type of dump. It's going to try to signal the processor, tell it, go ahead, take a dump. Now, this is a time, probably if you're getting to this point, especially if you're in a crit sit, which if you're at this point, you're probably in a crit sit. There are probably a lot of people on the phone worried about what it's going to do. This is definitely going to restart your system. So if you have any guests that you can still get to, that you could move off your system, you definitely want to do that at this point. Any guests that you can shut down gracefully, you want to do that at this point. This is definitely going to cause a restart. So we select it, and it's probably really hard for you to see because it's very small print. But all the way down here under recovery, there is PSW restart, and that's what we want. Now, like I said, this is going to restart your system, so it's going to ask you a lot to make sure that you want to do it. So it tells you this is what you selected. Are you really sure this is the one? I'm super sure. And do you want to execute the PSW restart task? I'm going to say yes to this one, but I want to quickly bring up that I have the operating system messages up here. So I found those. They're under daily and operating system messages. We also call this console sysc, and it shows me what the system operator sees. So this is usually like the operator user ID. It has its whole console right here. And you can actually see it taking the snap dump that we took before. So you can watch it in a little bit more detail doing that. And I'm going to have this up so that I can watch the PSW restart a bit more. So yes, I want to do this. It's in progress. This seems slow, but it's actually, this success is that it's sent that signal to the LPAR. So I say okay, and actually it's happening pretty quick here, but you can see, well, it happened so quickly it scrolled, but you could see it actually shutting down, taking the dump, and now it doesn't look super great. There are exceptions. That doesn't seem super great, but it's actually okay because it's in the process of restarting, and you can see now it's going back to operating, and you can see, I can scroll back up to the beginning here, and you can see this is all of the ZVM startup information. So that exceptions is just sort of, it happens at the point when the system is like fully shut down and trying to do sort of the loader and the restart there. So it looks bad, it looks a little scary because I didn't have anything on operating system messages, but that is normal. So a question about why it didn't ask for my password when I clicked yes, because this is a test system, they've nicely turned that off. Fully expect that in your production systems where you don't have such a close personal relationship with the security guy, they probably want that turned back on. A question about why not perform store status before the PSW restart. And so we're going to see, if we get to the standalone dump, we're going to see that store status is necessary for that. But it's not for the PSW restart, because actually all that's doing is sending a signal to the processors, and ZVM itself is kind of processing that the way it would process any other add-in signal from any other process within ZVM that add-ins. And it's ZVM sort of taking the dump and storing the status. So the HMC doesn't have to worry about that part of it. It only has to worry about sending that signal. So one quick thing that I want to mention, if you happen to be a very special person and you have access to the SE instead of the HMC, you can also do a PSW restart from there. The first couple times I logged on to the SE, I thought, oh, this is terrible. We don't have any PSW restart here. It's in a different place. Instead of being part of the choices for the LPAR, it's actually, you have to choose your LPAR and then choose a processor to send the signal to. Because like I said, all this is doing is sending a signal to the ZVM system that you need to shut down and take a dump. And so the SE lets you go another level deeper and choose a processor. I can tell you, unless you are massively unlucky, it does not matter which processor you send it to. I guess if you were having a super bad day, you might have a processor stuck in a really tight loop and you just chose the wrong one and sent it to that and it couldn't process it. But probably anyone you choose on the SE is going to be fine. All right. So it will restart and we'll go back to our puppy dog system here. Because the whole system restarted, I'm going to have to reconnect here. And remember my logon by password. Okay, so we see something different here. We see actually, this is a query CPU load. It's telling us our last start was a system restart after system failure SBC002. That's exactly what we want to see. That is the type of dump that a PSW restart generates. And in fact, we can see it here in our list of dumps that there it is. And we would load that in again with dump load 2, just like we did the snap dump. I'm going to skip that just because I want to make sure that we have some time to get to the really fun dump, which is the standalone dump. So like I mentioned, you could get really unlucky. The processors could be stuck in a really tight loop, and the PSW restart just might not work. You know, maybe you hit it and you just never see anything come up on the HMC. You know, maybe even sending the signal fails and you get some kind of an error message from the HMC. In this case, hopefully you've done your homework and you've been prepared. So I hope that after this, all of you will go back to your machines and you will check and make sure that you have a standalone dump disk defined. You need to go through some prep steps for that. They're all in Chapter 11 of CP Planning and Administration. It's not a lot of steps, but they're all very important ones. Please don't skip them. Each dump device for it is an entire 3390 mod whatever disk that you give it, or an entire SCSI LUN. You might want to have more than one depending on the size of your system, and it gives you some guidance there in Chapter 11. I see we have a question in the chat about what happened to PSA 002. I didn't know that was a dump type for restart dumps, so I'm going to go with that was before my time, but if anybody else remembers those, feel free to jump on the chat there. But anyway, so hopefully you've done this work ahead of time and you have the standalone dumper ready. And so what this is actually going to do is load a whole nother operating system that is capable of dumping the memory of the ZVM system kind of to these devices. So this is a big hammer to pull out. You know, there's nothing at this point that ZVM could do to restart itself or to take its own dump. You know, these happen in cases of really severe problems. Sometimes also like a hardware involved problem where something has gone really bad in a really weird way. Probably really rare for me to see these in the field. They're even rare for us to see in the lab. But when they happen, the standalone dump is invaluable. So, oops, I've lost the chat here. What we're going to need to do is, first of all, hopefully you have written down somewhere on a sticky note, or we have an internal wiki where we list all of these things, but hopefully you have your standalone dump disk addresses. And so we have those in hand. We're going to go over to our HMC SE. And the first thing we're going to do is stop all processors. This seems a little bit weird. I mean, our problem was that we couldn't get the system to stop and restart, and now I'm going to stop all processors. Well, you know, this is like a, you know, cartoon brick wall coming up for these processors. They're like the Roadrunner, and this is just going to cut them right off like you were flipping off the power switch to them. But that's good because then they just stop where they are. They're not writing out any additional information. They're not doing anything else. They're not trying to respond to signals that are getting sent to them. They're in a stopped state. So we stop all processors. It's going to warn us again. If you're Mr. Munson, it's probably going to ask you for your password. But I know a guy, so it doesn't ask me for mine. And there you see it went to not operating. So, you know, that's a really good example of what this status on the HMC shows you when you say stop all processors. It went from operating to not operating, even though, you know, in this case, I could restart all processors and the system would restart just fine. So it's not at all a statement about ZVM. It's a statement about the state of the processors. Now I'm going to do a load. So this is the same thing that I do if I was IPLing the system, but I'm going to do something special here. First of all, I'm going to take out either a notepad or here I have a text edit session, and I am going to really carefully write down what is in load address and load parameter. I'm going to make sure that I do that because I will need them later when I want to reload my system. And it will be really bad if I forget what those are. And because it's in the middle of a crit sit, I am probably going to forget what those are if I don't write them down. Then the load address I'm going to put in here is going to be the load address of the first of my standalone dump disks. So I know that it's Baker EZ06. I'm going to remove this load parameter. I don't want anything in here. And I'm going to click Store Status, because this time we do actually want the HMC involved in helping us store the contents of this LPAR. I say, okay, it's going to warn me. It's going to really warn me. And it's going to say it's in progress. And once again, we can flip back over to our operating system messages. goes away for a little while, and then it's going to come back, and we're going to see some messages, booting default, program starting, and then we get to see it actually doing the standalone dump. And standalone dump was successful. Now, like I said, this is a small system, so it went really quickly. Now that that's done, I'm going to load again. But this time, I'm going to put back in the IPL address and the load parameter where I want it to actually load my system so that my system comes back up at the end of this. So I put into C there because I have the operating system messages up over here. So I wanted to be able to watch that. Thanks, Perry. He remembers what a PSA 002 is. And again, you see it successfully loaded before you see anything in operating system messages. Again, because there's that little mismatch of time, I guess, between when it finishes and when it actually starts loading up the ZVM. Now, the chances of you being able to do a warm start after you've done a standalone dump are nil. I mean, you were not kind to the system. You took it down in the most violent way possible. And so it is not going to have anything in the warm start data. So you're going to have to do something like a forced start. It's very possible that you might lose some spool files and things like that, depending what state things were in. It's the price we pay for taking a standalone dump. So it's coming back up. So I'm going to go back over here. Now, there's no dump in my reader here because it didn't make, the ZVM system didn't make the dump. The operating system that the standalone dumper loaded made the dump and stored it there. So to get the dump, I'm going to have to attach my standalone dump disks to myself. And I use dump load 2 and I specified DASD because it's loading it from this DASD. And so I put in the virtual device number. And there you can see, like I said, this wasn't a very large one, so it didn't even take up a full volume here. I tell it, yes, I want to create just one dump file. If you're doing this on any kind of a real system, it will be much larger than a single dump file. But that will read it in, create it on your A disk, and you can go ahead and send that to IBM. In my last couple minutes here, I want to mention a couple things about standalone dump. So things are really dire when you have to take a standalone dump. And there is a possibility that CP memory could be corrupted or damaged in some way. So normally when we take any kind of a dump, when we take a snap dump or a PSW restart dump or ZVM generates its own add-ins, we don't dump guest memory. That's because you probably have things in guest memory you don't want us to see. And let's be honest, if it was a problem with ZVM, we didn't really need to see guest memory in order to debug that most of the time. But in the case of a standalone dump, it's not ZVM taking the dump, it's that standalone dumper taking the dump. So if it couldn't sort of figure out the structure of memory, it might have been forced to dump everything. So standalone dump is about the only type of dump where it's a possibility for us to get guest memory. And I think my husband would not be happy with me if I didn't mention that there are some security considerations with that. And it will always dump the object directory to that record of all of your user IDs. And so again, maybe not something that, depending on your security setup, that people are okay with that. Okay, so I think I'm going to skip right through. There is a lot else in this presentation. We have a lot of good charts in there and a lot of suggestions about how to better manage your system and better prepare for things to go wrong, because like I said, when you're in a crit sit situation, you want to have all of this stuff ready to go so that you don't have to scramble to find it while you're on the phone with 5 different vice presidents who all want to know when the system's coming back. So a question, is it dumped in the clear even if you had pervasive encryption enabled? So I'm guessing Rob Hamilton probably means encrypted paging for pervasive encryption. And so that wouldn't, once things are paged in, they're not encrypted anymore. So it's dumped in hex. It's not, but if you have the VM dump tool, there's no kind of encryption there. So any other questions in the chat? I think we're a minute past time. All right, well, if you think of any other questions, I hope that you never have to deal with any of these, but if you ever do, please feel free to reach out to me via email or via Twitter. I hope that you have a great last session. And I know that there was a discussion this morning about Star Trek and Star Wars. So I just wanted to quickly share one of my favorite quotes from Star Trek. And I hope you have a great Friday, and I will get out of the way because I'm sure you're going to start throwing tomatoes at your computer.
That's awesome.
I love it.
Very much, Emily.
I
That was
thought you were
great.
going to say something like nanu nanu or something.